simplify each radical expression. Here we have the square root of a to the fourth, b to the second. So I'm going to use the product rule for radicals to break that up as the square root of a to the fourth by the square root of b to the second. And then remembering our idea for if we're taking the square root of a variable to an even power, we basically just half the power. This is a squared times b to the first power. All right. 25, the square root of 25, x to the third, y to the fourth. Alright, so I'm going to do a little bit of work here before I break it up. That x to the third I'm going to think of as x squared times x. So I have the square root of 25 times x squared times x times y to the fourth. Now I'll break it all up. So that's the square root of 25 by the square root of x squared by the square root of x by the square root of y to the fourth. So now taking square roots when I can gives 5 times x times the square root of x times y squared. And now rearranging so the radical is last, this gives us we get what, 5x y squared by the square root of x. Exercise C, we have the square root of 50 x squared y cubed z squared. Again, let me do a little bit of work here before I break this up. 50 is 25 times 2. So let me first rewrite this as 25 times 2. X squared already has an even exponent, leave it alone. Y cubed, I'm going to break up as y squared and y, and z squared I'm going to leave alone. Alright, let's break this all up using the product rule for radicals. Square root of 25, square root of 2, square root of x squared, square root of y squared, square root of y, square root of z squared. Find the square roots when we can. 5 square root of 2, x, y, square root of y, z. Rearrange it so the radicals are last. Let's see, so I'd have 5x, y, z, and then I'd have a square root of 2 and a square root of y. Now, using the product rule in the other direction, I can write those two square roots, since they're being multiplied, as a single square root. And so then I'll write this as 5x, y, z by the square root of 2y.